Hello, back again. We're going to do the same thing with adding and subtracting and multiplying and composing and everything, but we're going to use it now instead of having like a formula and a number they give us. We're going to do it all from these tables. This one and the one below it with the graphing. This is it's like a conceptual method, because you don't know. We have no idea what x is or what g of x or f of x. I don't know what the functions are. I just know for these specific x values, these are the f of x values. And for these specific x values, these are the g of x values. They only give me these 1, 2, 3, 4. These only give me these 6 values for each one. But that's okay. Remember, f plus g of 0, this means f of 0 plus g of 0. And I can find f of 0 by using the table for f, which is this one. This means when x is 0, what is f? So I go to where x is 0. It's right here. And then I go over, when x is 0, f is 3. So this f of 0 is 3. So remember, the number inside here is the x value. So I go to where x is 0, and then I find that f of x is 3 when x is 0. I do the same thing with g. G of 0, I go to where x is 0 on the g table. Then I go across and I see that g of 0 is also equal to 3, conveniently. So f of 0 plus g of 0 is 3 plus 3, which is 6. Let y'all just kind of absorb that for a couple seconds while I... All right, so now we can do the same thing here. Remember that this is f of -1 minus g of -1. This f minus g means you can write it like this. Now I can just evaluate these two functions using the table. I go to the table for f. I find where x is -1. It's the top row. When that happens, when x is -1, f of x is 4. And I do the same thing for g of -1. Ooh, I wrote plus and it's minus. Silly goose. When x is -1, g is 2.5. 4 minus 2.5 is 1.5. These are my answers. F divided by g of 2 is f of 2 over g of 2. And so to find f of 2, I go to the f of x table and I go to where x is 2 and I see that f of 2 is 1. And to find g of 2, go to the g of x table, go where x is 2 and I find it's 0. Uh-oh, that's not good. So if you recall, I said, when we did f over g, I said, this works as long as g of x is not 0. Whenever you have a 1 divided by 0, this is not a meaningful number. You could say undefined. That's a reasonable thing to say there. You could probably say does not exist, but that's kind of a weird way to say that. 1 over 0 is undefined. It's better to say undefined. I'm going to leave this one to you guys. I'm just going to write this, f of -1 times g of -1. I'm going to allow you guys to figure out what these values are, multiply them together, and get an answer. That's for you. Because I want to do the composition ones. So these ones are done by working on the inside. Start that whole sentence over. These are done by starting on the inside and working your way out. This says f of g of 3. So this means I'm going to plug whatever g of 3 is into x. I'm going to say that again. I'm going to plug whatever g of 3 is into f. I think I said x before. So f of g of 3 means we start on the inside with g of 3, which we can get just by looking at our table. So g of 3, when x is 3, g is 1. So this means f of g of 3 equals f of 1 because g of 3 is equal to 1. Then I can evaluate this, hopefully, using the table. F of 1, I go to the f of x table and I see where x is 1 and f of 1 is 2, so this equals 2. So you can kind of do these. These are like, once you do a few of these, it starts to get it gets a little faster. I'm doing it kind of slowly, but that's because it's the first time we're doing it. But you all will probably get a little faster at this. So same thing here, f of g of 0. So I start on the inside with g of 0. I write the f out there, and I evaluate g of 0 by finding the g of x table, which is this first one. I go to where x is 0, because that's the number in there. I go across to the g, and I see that the g of 0 is 3. So this f of g of 0 is now f of 3. And then I evaluate this by using the f of x table when x is 3. F of x table, x is 3, f of g of 0 is equal to 0. And this is the same deal, but they started, this time the f of x thing is on the inside and the g is on the outside, so it doesn't matter. Start on the inside. F of -1, f of x table, x is -1, f of -1 is 4, it's g of 4. And now g of 4, I go to the g of x table, I find where x is 4, and I get it's equal to 3. So this equals 3. And we can also do this in theory. It doesn't really matter. They use the same function twice. That's fine, as long as it's meaningful. But we'll see what that means in a minute. Start on the inside. What's f of 2? And go to the f of x table. And x is 2. It's equal to 1. So now I just stay on the f of x table here. I use it twice. F of 2 is 1. F of 1 is 2. So this equals 2. And last but not least, we do g of 0. So that's g of 0 in here. We go to where x is 0, it's equal to 3. And now when x is 3, g is 1. So I use tables to do that. They just tell you what the answers are. You just have to know the right place to look. It's a little confusing if you accidentally use this for the x, you'll get the wrong answers. But that's why I kind of have been like with my pencil, like moving around and like saying things like, go to the f of x table, find where x equals 0, and then this is the answer. The last thing we'll talk about today is you can do this exact same thing, but with a graph. Like you could think about this graph as like being a list of points. Instead of g of x on a graph, you would probably call that y, but you could also call it g of x. And so like this first row of this first table would represent the point where x is -1 and y is 2.5. At this point, this row of the table would represent the point where x is 0 and y is 3. This would be 1, -2, so on and so forth. This last one would be 4, -3. So like these are like points. These rows are like points. They're just like associated numbers, like a set of numbers. In coordinate geometry, we call them ordered pairs. And so this last slide just does the same thing, except instead of giving you a table, they give you a graph, but this is just like a table. Like they organize it the same way. Like when x is 1, g of x is 1. And when x is 1, 2, 3, 4, and g of x is, I think that's also 4. That point is 4, 4. I can tell you that the thing about these that get confusing is that you forget which is f and which is g. It's like easy to like be looking for the f and use the g one instead. Just be careful. This one is convenient because I know that the f of x is red and the g of x is blue, but if it's not colored, it can be a little harder. So this is equal to f of 4 plus g of 4. So I'm going to do it like this: f of 4 plus, and then the g of x ones are blue, so it's g of 4. So what I do is I just go to my graph and I see this is like when x is 4. So I go 1, 2, 3, 4. F of 4 is a red one, so it's right here, and the y coordinate tells me the value of the function. So when x is 4, f of x is 1. And when x is 4, same place, g of x is 4. So 1 plus 4, that equals 5. So you can use this graph just like we used the table in the previous one. The x's are always along the horizontal axis. Let me do that in black. The x's are always on the horizontal axis. And the functions are always along here. In this case, it's both f of x and g of x because they're both on the same graph. But the horizontal the vertical axis tells you the f of what the function values are. So f times g of -1. Let's see, f of -1. Well, I guess I'll write this out. It's f of -1 times g of -1. That looks like a minus, doesn't it? Times g g of negative 1. When x is negative 1, the red function is 1, 2, 3 units down, so that's negative 3. And when x is negative 1, the g of x is just 1 unit down, so that's negative 1, which is 3. G minus f of 3, well, 3 is an annoying one, isn't it? 1, 2, 3, there's no dots, but I can look. Let's see, G is the blue one. And F is the red one. So my point's here at 1, 2, 3. The blue one looks like it's at 3. And the red one, 1, 2, 3 is at 0. So it's 3 minus 0, which is 3. This is f of 1 over g of 1. Remember, we got to be careful that g of 1 is not equal to 0, because if it is, then we can't do this. F is the red function, so when x is 1, f of x is negative 1. G is the blue function. When x is 1, it's equal to 1. So this whole thing is negative 1. And 8. Oh boy. Hopefully that's that last dot. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right here. So I do g of 8 first. That's the blue one. That looks like it's down here at negative 1. Then I do f of 8, which is the red one, and that looks like it's 2. So it's negative 1/2. So I recommend that you can watch this last bit again if you want on YouTube or something. But being able to do these tables and charts is pretty important. There's a very good chance I'm going to ask you to do this on a written assessment at some point. I'm just going to give you problems like this with pictures like a graph or a table and ask you to do them. So make sure that you know how to do this. We'll do some of them in class too. Bye.